So today we'll continue the discussion with the data link layer. So you are aware that data link layer is a layer, just now we saw that it is the second layer in the OSI model, and in the TCP/IP protocol suite it is the lowermost layer. These two layers, physical and data link layer, they're combined in this. So we'll see what the data link layer has to do. So this is again the same picture in different colors. Okay, you have different protocols. What is this? ARP has to do with the address resolution protocol, how you find out the physical address when you have the IP address alone. Reverse address resolution protocol, that is how you have the physical address, from that you can find out the IP. So these are some protocols that operate in the IP layer. So you will pick up these things later, but I'll mention from time to time. I'll mention some abbreviations so that you are familiar with it. FTP, you are aware. FTP is file transfer protocol. HTTP, what? Hypertext transfer protocol. DNS, domain name service. So this is symbol mail transfer protocol. Telnet, SSH, all those things are there. So we'll see that little by little. So this is something which you are aware of, that is we are transferring data from one node to the other. So this is how the network is made. You say this is your sender and this is your receiver, and across this you have intermediate nodes, and the nodes are interconnected by links. So, and each of these nodes is, someone is requesting access. Okay, Divagar Mahesh. Okay, so this is what do you say? The data link layer is concerned with sending data frame from node A to node B. It is not concerned with sending this packet or the data frame from node, the source to the destination. It is just point to point sending is concern of data link layer. At each of these nodes, there is the process of encapsulation as decapsulation happens. So each of these intermediate nodes are the routers. So you can't pull a direct line from your computer all the way to the Google server. Rather, we have intermediate nodes, and as you are aware that routers, they operate in the lower three layers, that is the physical layer, data link layer, and the network layer of the protocol. So network layer of the protocol suite. So here the routers will check what is the content of the data link layer frame. It will also pass this thing to the network layer where the IP is checked, other fields are checked. So it happens, this encapsulation, decapsulation happens intermediate, and again encapsulation happens and it is transmitted. So this figure should make it clear. So you have the OSI model again shown here. Now on, we won't show this picture time and time. This is the last time in this set of slides we'll show this thing. So you have this network access, IP, the transport layer, and then the application layer. Now here you see that there are two characters which are commonly used in this cryptography, all those business. Bob, Alice. So Alice and Bob, they are trying to communicate, and what happens, it is Alice is sending frame, the data link unit. The data unit in the data link layer is called as the frame. At the physical layer it is called as the bits, and still higher up to the data link layer, the network layer, you call the data unit as packets. Okay, so frames are sent from Alice network. This is Alice network, and to its intermediate router R2. So it is getting from the data link layer through the physical layer to the physical layer of the router R2, and then it's passed to the upper layer, that is the data link layer. Here in this step there is the process of decapsulation. Again the router will add its, so what happens is that for Alice will add something called as a what is a physical address. We'll come to those discussion, and here the router will add as add its physical address as the source address. So we'll elaborate that thing later. So there is the process of decapsulation and again encapsulation. It's going to the next node, then from R4 it is going through this some other network and it is going to R5, again the process of decapsulation and encapsulation, then R7 decapsulation followed by encapsulation, and finally it is reaching Bob's network. So Bob's network, where the Bob receives this message. Now this is how the communication happens. You have intermediate nodes and which are interconnected by links. This R2, R4 link, R5, R7 link. So links are there, and these are intermediate nodes. So we are communicating in near real time as well. So we saw this thing earlier. So the Datalink layer provides services to the network layer, and the network layer supplies all these data in the form of packets. The Datalink layer, one role is framing. Framing is an important function of the Datalink layer. So, and it adds, to make frames, it adds something which is called as a header, and the other one is called as a trailer. Header contains the source address and the destination address of the frame. So source address and destination address, these which are added by the Datalink layer, they are called as the physical address, or otherwise you call as a link address, or even you call as a MAC address. Whatever you call as a MAC address is the physical address, and the destination machine MAC address. So destination machine MAC address is found out by using something which is called as address resolution protocol. So for this Alice machine, the destination physical address will be the physical address of R2, the network interface of R2. But we'll see that IP address is something which is used to really convey it from this network to this network, Alice network to Bob network. But the physical address will change on each jump, on each hop from one node to the node. We'll see that. Okay, so reliable transmission of data frames between two nodes. That is what is the role of a Datalink layer. Now these are two Datalink layer devices. This is a network card. This is a what? This is a switch. So these two are Datalink layer devices. Then you have, so your network interface card is a device which operates at both the physical layer as well as the Datalink layer. So physical layer as well as the Datalink layer, it has both these functionalities. So now there are two sub layers. Be aware of this thing. We'll discuss this thing in bit more detail later. I've just included it for the sake of completeness. That's what I'll say. Datalink layer has two sub layers. One is called as a MAC sublayer, medium access control sublayer, and the other one, that is, this is MAC sublayer, is concerned with the shared channel access and all those things, and the Datalink control sublayer. Datalink and control sublayer is concerned with the functions like framing, then error control, flow control, and all those things are done by these layers. So over a broadcast link, that is when it is using a shared channel, these two layers are defined. But when you are on a point-to-point link, that means router-to-router link or node-to-node link, these two layers are not defined. Rather, it's a dedicated channel sort of. So you have really established a link. So you have this only other functionalities do have a role. That is the flow control, error control, and framing. These three functionalities are there. So we'll elaborate on these things in the subsequent lectures. But for the time being, be aware that there are two layers in the Datalink layer, which is called as a medium access control sublayer and the Datalink control sublayer. Now these are the functions which we already seen of the Datalink layer. In the network models lecture, we saw that. So framing is an important function. You are aware that frames are the data units in the Datalink layer. Then there is physical addressing. So physical addressing has, you call it as a link address or the MAC address. You add either the you obviously need to add the receiver address and the sender address. So sender address is optional. I accidentally typed it the other way around. So MAC address of the receiver and or sender, they should be reworded like that. Okay. This then error control has some mechanisms. So the data link layer brings about error control. There are error detection schemes as well as error correction schemes. So you need to provide a reliable service to the network layer. So data link layer has some mechanisms to bring about error control. And again, flow control is fast sender. We discussed this topic there. Fast sender should not drown a slow receiver. That process, that is a task of the data link layer. Now the issue here is that the flow control and error is also task done by the higher layer, which is called as a transport layer. Transport layer also does the flow control at a much higher level. There is this transmission control protocol, TCP, in the IP protocol suite, which does this task in a very much more higher level. So using sequence numbers, acknowledgements, all those things. So when we come to that point, we'll discuss this flow control in a much more detailed way. Here we'll have a discussion from the point of view of data link layer. Okay, fine. So framing. So framing, this is a task of the data link layer. It has to organize the packets which it gets from the network layer to frames, and then you will add the sender address and the receiver address. So both are physical addresses, the MAC address. So who will tell the data link layer the MAC address? The data link layer should be aware of the MAC address. Okay, fine. Someone asked something? Router comes, router runs this physical over the physical link, physical layer, data link layer, and the network layer. So router has to run over these three layers. Hello.
Sir, router MAC address table
there is something which is called as an address resolution protocol, ARP. So address resolution protocol will allow this data link layer to be aware of the IP addresses to which it is connected. So that way you will be able to identify what will be the, so there are two situations. One is the frames which are data link layer frames, the data frames which are destined for the same network within this network. Now there could be the other case where the frames which are destined outside the network. So these two situations can come. So when we take up physical addressing, we'll discuss on that. So these two situations are to be handled. So and we'll see a practical case as well where the router comes in. So the full picture will be clear only when you take up IP addressing. When you get to the network layer, really the situation becomes clear only there. Okay. For the beginning, we are taking up the topic in small bits. So you have the physical layer which carries the raw bits, the data bits, zeros and ones. It doesn't have anything. Now the frames are the data units in the data link layer. So how can the frame boundaries be set? Because there are only zeros and ones. So frames, depending upon the data link layer, the frame sizes can be either fixed or variable. So different protocols have come up in the past. Say something which is called as an ATM, asynchronous transfer mode. It has variable size frames. Ethernet has a fixed size frame. So the frames, and if there isn't enough data, you can add junk data, that is also there. Or if there is, usually you won't send the message even if it fits in one frame, you won't send it like that. You can say that it's the flow control, error control strategies become efficient when the data or the entire message is split up into smaller frames. Two approaches to do framing. One is called as the character oriented approach and the bit oriented approach. You may be aware of these two. So this is a character oriented approach. It's also known as, this is AK, you know this, alias. So also known as byte oriented framing. So you will add bytes. So bytes which are specifically called as the flag bytes at the beginning and end of the frame to indicate that this is a frame. So after, just before your header and after your trailer, you will add this flags. Now this flags will be an 8-bit character. It's a special character. Now the question comes that what if the data itself contains these flag characters? Data can have, these are special characters. Say for instance, I include an 8-bit character like 4 zeros and 4 ones as a flag. Now the data might also contain such a sequence. In such a case, you add something which is called as an escape sequence. This is what you pick up in the programming classes, isn't it? You add an escape sequence to indicate that this particular character. So this is escape sequence is another special character which is added just in front of this data, which is similar to the flag bytes. So this is byte oriented framing. So this will make sure that you are interpreting, the receiver side is interpreting this as data. It will understand that this is data. So again, there could be situations where this escape sequence itself can become could be part of the data. So in such a case, you will add another escape sequence. You will prefix another escape sequence just to indicate that the sequence that comes next is a data rather than an escape sequence. So this process is called as a byte stuffing. So you are stuffing a byte, 8 bits, an escape sequence is stuffed into the data frame and it is unstuffed in this process, unstuffed at the receiver side. Is it clear? Or do I need to explain it further? Someone?
So
Okay,
clear.
this is something which you do in programming. Escape sequences are there. Same manner, you add some ASCII character, for instance, to indicate that the data that is coming is a flag. And if the escape sequence itself forms part of the data, you can add another escape sequence, prefix another escape sequence to indicate that this is the data. Okay. So then again, bit oriented framing is there. Bit oriented framing, you have bits, you have some delimiters in the form of specific sequences to indicate that this is a frame. So we are moving towards bit oriented framing. Most popular ones are bit oriented framings because you use Unicode nowadays. Unicode encoding is used. So these are 16 bits or 32 bits rather than the 8-bit characters which are used in character oriented framing. These are much more compatible with our way of data, the type of data we have, because character oriented framing was more suited for text based applications. Now you have both text, audio, video, all those things. So you have multimedia, that is what the term would be. So in such a situation, the flag bytes concept won't work, rather you will use a sequence of bits. Again, here also you could have a situation where this flag bits, flag sequences could be part of the data. In such a case, an extra 0 is added. It's prefixed to indicate that this is a data bit. So this process is called as bit stuffing, and the reverse one is called as a bit unstuffing. Okay, so this reverse process is called as a bit unstuffing. So again, you have this second function which is of Datalink layer, which is called as a physical addressing.